the assessment for this course, but the information that I obtained from the course coordinator is not changed yet. Okay, so okay, and other thing is regarding the reference. So I urge everyone buy the books. If you don't want to buy the hard copy, please buy the e-books, the soft copy one. Okay, it's around 26 ringgit. Okay, because most of the lecture notes, most of my material for this course, I use that books. Okay, but I cannot explain page by page because we have a time constraint. So if you want to know more about the example, you can refer to the books. Okay, in the books also you will have extra exercise. Okay, at the end of each chapter. Okay. Okay, so for the most important part here is academic honesty plagiarism. So assignment should be done individually. Okay, so I've noticed that from my previous static course, there is students tends to copy their friends in test and exam as well. So so copying of works from other subject group or from other sources is not allowed. Okay, for those who copy their friends or copy to other sources when doing a test or final, you will be called by the school administration. Okay, you will be failed in this subject. Okay, if we found that you copy from other sources. Okay, this happened to statics students previously. Okay, so please make sure when you do the test, assignment, final examination, please do it by your own. Okay, and don't copy to the other sources or ask a help from others. Please don't do that. Okay. So please read. Please make sure. Uh, it is not acceptable to retype existing stack and just acknowledge the source as a reference. So meaning said, this is regarding when you do some things, when you want to copy from other sources, you need to rephrase and then put the reference. So this is basically it's not related for this subject. Okay, and then the attendance, the student should adhere to the rule of attendance as stated in the university academic regulation. Student must attend not less than 80% of lectures hour. Okay, so the student will be prohibited from attending any lecture and assessment activity upon failure to comply the above requirements. So if you attend less than 80% of the lecture hours, you cannot you cannot take your final examination. So please make sure you attend all the lectures. Okay. Okay, and then all the teaching and learning materials associated with this course are personal use only. Okay, don't distribute this material to others. Okay, so it is just for your personal use only. Okay, reproduction of the material in any form for any purposes other than that, other than what it is intended, is prohibited. Okay, so I hope everyone already learns, already can read this CI. Okay, so this is the online learning teaching plan. Okay, basically we do this course with online learning. So this is how we distribute the lecture hours according to the CLO. So basically we will do in my class I will do online lectures and I will record these online lectures. Okay, and then I will put the recorded lectures in the e-learning. Okay, so you can view back the lecture. Okay, this is the correct one. Okay, you have two tests and each test 21%. Okay, each test contribute to the 21% where you will have 3 questions, 7% for each question. Okay, and 2 tests and the assignment you will have around 4 assignments. Okay, 2% for each assignment. Okay, so the total carry marks before taking the final examination is 50%, which is for 42% from test and 8% from assignment. And then for your final examination, you will you will have another 50%. Okay, another 50%. Okay, so I think that's all for the course information. So if you want to know more about this course information, you can read. I already put this course information in the e-learning. Okay, so this is another important thing regarding the lecture schedule. Basically, this is the schedule that has been made by the course coordinator, where the topics that you will learn according to the weeks. Okay, week 1 you will learn the introduction, rectilinear motion. Okay, week 2 you will learn the continuity of the rectilinear motion, and then we will go to the chapter 3 on the curvilinear, which is kinematics. Okay, and goes to the last week, which is week 15. Okay, so you can go through to this lecture schedule. Okay. Okay, here is the assessment. Okay, the assessment here. For test 1, you have 3 questions, where 7% for each question. Okay, test 2 is also the same, 3 questions and 7% for each question. So this is the total marks that you will obtain for this course. Okay, 100%. 50% carry mark, 50% final examination. So the passing mark for this course is 50%, which is you need to achieve at least grade C. Okay, clear? Any question?
Of course, so good.
Okay. So I think that's all for this for the introduction, okay, of this course. So please make sure you understand the whole assessment of this course. We have 2 tests and also the assignment as well, and then we will have a final examination. Okay, so regarding the topics, I not received the topics yet, so I will share the topic once I receive what will be the topic that we cover in the test 1, test 2, and the final examination as well. Okay. Okay, so this is okay, actually I not upload yet this lecture note. So okay, so there is one question. Will the final exam held online? Still not finalized yet. What would be the platform for the final exam? Either online or face to face. I'm not sure. Okay, it depends on the school decision. Okay. Okay, so this is for chapter 1 and chapter 2. Basically, chapter 1 is very short, chapter, just the introduction to the dynamics. Okay, what is the difference between dynamics and statics. Okay, so on this lecture note, you will have 2 chapters, chapter 1 and chapter 2. So the below one is my name. Okay, so please make sure that you know which section that you enroll for. So this lecture is for section 11 and section 12. Okay. Okay, so this is the scope of study for this dynamics. Okay, so the subtopic is actually your the chapters in the books. Okay, subtopic is the chapter in the book. So rectilinear motion is a chapter 2, curvilinear motion is a chapter 3, relative motion is a chapter 4. Okay, but on each chapter there is a main topics. Okay, which is for chapter 2 to chapter 4 is regarding the kinematics of particles. So means that you are dealing with particles. And what is meant by kinematics? Kinematics means that you just study the motion. Okay, you just study the motion of the particles. Okay, and for chapter 5, 6, 7, 5 and till 7, which is force and acceleration, work and energy, impulse and momentum, and also the impacts is covered by the kinetics of particles. So what is meant by kinetics is you study the effects that cause the motion. Okay, what is the force that cause the motion? So now you will learn, that's why you learn here force and acceleration. Okay, you learn the force and the acceleration. The force that causing the particles to move. Okay, and after you finish the particles, you will learn on the rigid bodies. Okay, when we talk about rigid bodies, means that we will consider the dimension and also the bodies is not deformed because the body is in rigid condition. Okay, same thing. We will learn on the kinematics, which means that we just learn on the motion, and then after that we will learn on the kinetics of the rigid bodies. So now we will learn what is the cause of the rigid bodies to move. Okay, what is the force, what is the energy. Okay, so this is the topics that will be covered in this course. Okay, so so this is the introduction to this dynamics. So what is mechanics? Basically, when you learn static and dynamics, so the main topics of static and dynamics is mechanics. Okay, usually in other university they just use the name of the subject is just mechanics. Okay, below the mechanics you will learn on statics and dynamics. So in this course, in this you will learn one by one. First you learn statics and then you will learn dynamics. Okay, so what is mechanics? Physical science deal with the state of rest or motion. Okay, rest. Rest means that in previous subject you learn on statics means that the states of the object, particle or rigid body is at rest or is not moving. Okay, and now you are moving to dynamics, which is in motion. Okay, of body under the action of force. Okay, why we need to study mechanics? This science form the groundwork for further study in design and analysis of structures. Okay, so when you are designing the system, designing the structure, you need to know how to do the analysis. Okay, in previously you learn how to do the analysis on the statics. Okay, means that the object is not moving. Okay, so you do the statics analysis. Okay, by finding the force, the reaction force, in the structure. Now, in a machinery system, the structure will moving. Okay, it's in motion. So you need to know how to do the analysis when the structure is in motion. Okay, so this is the importance for learning the mechanics. Okay, so below the dynamics, you will have kinematics and also the kinetics. Okay, the main part is kinematics, and for the kinematics, you will learn on the analysis on the particles and also the rigid bodies. And for the kinetics, also you will learn on the particles and rigid bodies. Okay. Okay, so here is the same thing. Okay, as you may notice here, for the kinematic study, okay, for the kinematic study, you only learn on the motion. Okay, but for the kinetic study, you will learn on the motion plus with the force. Okay, so this is the difference between kinematics and kinetics. Okay, so motion here can be in a rectilinear. Rectilinear means straight, just straight line motion. Okay, and also it can be in a curvilinear, meaning that the motion is in curved path. Okay, the motion of the particle or rigid body is in a curved path. Okay, so any questions so far?
No, sir.
Okay, yes, sorry. Okay, so when we deal with a motion particles or in a motion object, there are several parameters that we can use. okay, to measure how the object is moving. Okay, the first one is distance, displacement, velocity, speed, and acceleration. Okay, so my question, what is the difference between distance and displacement? Does anyone here know what is the difference between what is the difference between distance and displacement?
Displacement is the shortest length between 2 points, and distance not necessarily to be the shortest length.
Displacement is the shortest distance. Okay. Okay, so I will explain after this on the next slide. All right. Okay, so what is the difference between velocity and speed? Anyone want to try?
Doctor, hello, Doctor.
Yes.
Okay. I think it's the form of the we call it that velocity is a vector form, and the speed
Okay.
is in scalar form, I think.
Okay. So you will get the answer after this. So basically, it's correct. Velocity is actually a vector form. Speed is actually a scalar. Okay, same goes to the distance and displacement. Distance is a scalar unit. Displacement is a vector. Okay, what is difference between scalar and vector? Scalar is only has a magnitude, but vector will have a magnitude with the direction. Okay. All right, so acceleration is also a vector unit. So direction is very important, okay, when the object is in motion, because we want to know where the object goes to, okay. All right, so this is the difference between distance and displacement. All right, so what is distance? Distance is a scalar quantity, length of the path traveled by a point, okay? And we use the units here is centimeters, meter, miles, or light year. So it has several units. Usually for this course, we will use centimeter or meter. Okay, so for displacement, we will have it is a vector quantity. Okay, difference between final and initial position a point. Okay, but for this displacement, we need a reference point. Okay, where the object start from. But for distance, we don't need the reference point. We just want to know what is the distance between A and B, let's say. Okay, we don't need to know where is exactly point A, where is exactly point B. We just need to know what is the distance between A and B. But for displacement between point A and B, we need to know where is the location of point A and point B. Okay. So because when we know the points, the location of the point, we will know the direction. Okay, the direction of the object. Okay, so the units is still the same for distance and displacement: centimeter, meter, miles, or light years. Okay, so usually we will use centimeter and meter. So this is the difference between distance and displacement. Usually from Kuala Lumpur to Johor Bahru, we know that it is around 400 kilometer distance. Okay, 400, it's just 400 kilometer. Okay, but then if we refer to displacement, we need to know the reference point, where the start, where is the location of the car from Kuala Lumpur to Johor Bahru. So now we will know that, let's say we assume that the car move from to the right is positive. So we will put here positive 400 kilometer. Okay, usually when we deal with related to the direction, we will focus on to the right is positive, outward is also positive. This is based on the assumption. Okay, to make it easy, we just assume that to the right is positive, outward is positive. Related x and y axis. Okay, so here is a difference between velocity and the speed. So velocity is a vector quantity. Velocity is actually the rate of change of displacement. Okay, the rate of change of displacement. So meaning that in order to get a velocity, you can get it from displacement. It's based on rate of change of displacement. Basically, if we can write in terms of mathematical formula, the rate of change of displacement means like ds over dt. Okay, ds over dt is equal to velocity. Okay, the rate of change of displacement. Okay, rates here means the times and displacement means displacement. Okay, so units now, since here is this displacement, the below here is the time, so you may notice that it should be cm over s, meter over s, mile over s. So the units that usually we use for time is second. Okay, so that's why here is over s. Okay, due to this t. Alright, for the speed is a scalar quantity, is a magnitude of rate of change of displacement. So basically, when we talk about the speed, it's just we want to know what is the speed. Okay, no direction. Okay, so the unit is still the same, cm per second, meter per second, or you can write in term like this is also the same. Okay, you will notice that in the books it used like this. It's the same like meter per second. Okay. Okay, so acceleration is also the vector quantity. Okay, it's a rate of change of velocity. Now it's a rate of change of velocity. So in order to get the acceleration, means that you need to differentiate velocity with respect to time. So means that acceleration is dv over dt is equal to acceleration. So since here is velocity, here is time. So velocity is what? It can be meter per second. Time is what? Second. So meter per second is equal to meter per second squared. Okay? What is mentioned here? Or usually we can write in terms of like this. Okay? So this is the units for acceleration. Okay? Is a rate of change of velocity. Okay, any questions so far? Okay, clear? I hope everyone is clear with this. This is basics parameters to measure the motion of the object. Alright, so this is what I mentioned previously. Okay, the symbol that we use for displacement is small letter s. The symbol for velocity is small letter v, and the symbol for acceleration is small letter a. Okay, so here is what is displacement. Okay, you can get displacement by integrating velocity. Okay, and you can get velocity by integrating acceleration. Okay. Okay, like I mentioned, A is acceleration is equal to dv over dt. Okay, and this v here is equal to ds over dt. So you can obtain the acceleration by integrating displacement 2 times with respect to time. Okay, you get d2s over dt squared. Okay, it's also the same as dv over dt because v here is equal to ds over dt. Okay. Okay, so here, so this is the relationship in a graphical form when you have a graph displacement against times. Okay, displacement against time. You know that in order to get velocity, velocity is equal to ds over dt. So this means that ds over dt is related to the gradient of the st graph. Okay, rate of change is related to the gradient of the displacement against the graph. Okay, you need to understand this form because in the question you need to know how to draw this graph. Okay, from S to T to V to T to A to T as well. Okay, so for the graph of V against T, velocity against time, you know that acceleration is the rate of change of velocity with respect to time, or means that you know the gradients of the VT graph will be the acceleration. Okay. Okay, in order to draw acceleration against time graph means that you need to know what is the gradient of the graph of VT. Okay, so from displacement, if you differentiate displacement, you will get V. If you differentiate V with respect to time, you will get A. Okay, d over dt. Alright, so if there is a back process where from acceleration, if you integrate, you will get velocity. If you integrate velocity, you will get displacement. Okay, from displacement, differentiate, you get velocity. From velocity, differentiate, you get acceleration. Okay, from acceleration, if you integrate acceleration, you will get velocity. If you integrate velocity, you will get displacement. Okay, so you need to understand this concept. Okay, integration and differentiation of the parameters displacement, velocity, and acceleration. Okay, so here is in the form of a graph. Okay, here is from here, from bottom one to the top one. If you differentiate, you will get okay, like this. If you have let's say here is just I put the constant here is 10. Okay, it's a 10 here. If you integrate 10, you will get, let's say you will get 10x or 10t. Plus with t. Okay, if you integrate this one, you will get a 10t squared plus c plus with d. You will notice that from constant here, 10 with just a straight line constant. If you integrate this constant, you will get a first order of line, okay, which is 10t with a gradient line here. Okay, if you integrate again, you will get a second order, which is the quadratic form. So you will notice that your graph will be like this. Okay, so from here, this is the arrow mentioned that from here you integrate, you will get the shape like this. So please make sure if the gradient like this, if you integrate the line with the positive gradient, you will get this shape. Okay, let's say you have a negative 10, negative constant here below the t axis. Okay, so you may notice that you will get, when you integrate, you will get a negative slope line. Okay, and if you integrate again this negative slope line, you will get this kind of shape of quadratic form. Okay, so this is for the integration. When you integrate constant, you will get a first to the second order of the line. Okay, okay, so from here you can differentiate. Okay, when you differentiate quadratic, you will get the first order. Okay, which means that in a straight line. When you differentiate the straight line, you will get a constant. Okay, any question for this figure? Is it clear?
No, sir.
Okay, so this is important because you need to draw a ST, VT, and AT profile. Okay, with respect to the line. When you integrate the positive gradient line, what will be the quadratic form? When you integrate the negative profile, negative line, negative gradient line, what will be the quadratic form direction? Okay. Okay, so here is in the motion analysis, there is a special case where you have a constant acceleration. Okay, constant acceleration means that you don't need to use integration and differentiation of the equation. Okay, let's say you have the equation of displacement. In order to get the velocity, you need to differentiate. You need to differentiate the equation of displacement, and then you differentiate 2 times the displacement equation to get the acceleration. Okay, but if you notice that the question or the problem is in a special case of the constant acceleration. Okay, how to know that your problem is on the constant acceleration? If you have AT graph, the graph will looks like this. It's constant. Okay, constant value for AT graph. You will have a constant value for AT graph. So this means that the problem is in constant acceleration. Okay, if the problem give you V against T graph, how to know that the problem is in constant acceleration? Meaning that it is a straight line graph, right, with a gradient. And also, if like this, you know that if this graph like this for V against T, means that there is a zero acceleration. Okay, it's still constant. Okay, zero acceleration is still a constant acceleration. Okay. Alright, so if S against T graph, and it will show the graph like this. Okay, so this is how you determine that the problem is constant acceleration or not. Okay, if the case is not a constant acceleration, means that you need to use integration and differentiation analysis. Okay. So if the special case, in order to determine the velocity of the particle, you can just directly use this equation. V is a final velocity. V is final velocity is equal to initial velocity plus with acceleration time with the time. Okay, this one is final velocity. This one is initial velocity. Okay, if you want to determine the displacement, you can use this equation. Final displacement minus with initial displacement is equal to initial velocity time with time plus with half acceleration time with time squared. Okay, so you have another equation that related with velocity and displacement. Okay, it depends on situation. Okay, the difference between this equation and this equation is that in order to find the final velocity, you need the time here. Okay, sometimes in the problem you don't have information of the time. Okay, means that you need to use this equation. Okay, this equation just the relation between velocity and displacement. Okay, you need to understand the concept of the problem. Okay, sometimes some of the parameter is not provided in the question, so you need to understand. Okay, which question is suitable to be used. Okay, so there is a condition where your velocity will become zero. So when the velocity is zero, when in the problem it's mentioned that the particles or the rigid body is start from rest. Okay, start from rest means that the initial velocity is equal to zero. Okay, and then sometime in the problem it's mentioned that the particle is stop moving, so means that the final velocity is equal to zero. Okay, and sometime in the problem it's mentioned that the particle change direction. In order to change the direction, the particle need a time. Means that a split second of time to stop in order to change the direction. So that's why we say that the velocity will become zero when we want to change the direction. Okay, so you need to understand this term here. Okay, velocity is 0 when this is the important term that may help you to solve the problems in this course. Okay, you will notice that this is very famous terms that you will face for the whole topics. Okay, for the whole topic. So make sure you understand this term. All right. Before we move to the example, I think we will take a break around 5 minutes. Okay. We will start at 11:52. If you have any question, you may ask. Okay guys, so let's continue to example. Okay, one more thing. Is anyone here want to buy a hard copy book? I know. If anyone here, for if you are at UTM, so means that you don't need to pay for the postage fee. Okay, so the books without the postage fee is 40 ringgit. Okay, you can come to my office to take the books. But it depends on the stock. Okay, if we still have the stock, then you can get that hard copy. Okay. So for those who need the hard copy ones, please PM me as soon as possible because we have a limited stock of the book. Okay. So first come, first serve. Okay, let's move to example 2.2. Okay, so a particle move on a straight line. Okay, so when we talk about straight line, meaning this is a rectilinear motion. Okay, with the relationships of s equal to t cubed minus 9t squared plus 15t meter. Okay, this is the unit. Determines the displacement, velocity, and acceleration when t is equal to 2 seconds. Okay, determine also the distance traveled for the duration of 0 to 6 seconds. Okay, so now you have the equation of displacement, which is s equal to t cubed minus 90 squared plus 15t. So this is your displacement equation. Okay, so the first question is you need to determine the displacement, velocity, and acceleration at t equal to 2 seconds. So for displacement, you just substitute the value of t equal to 2 seconds in the displacement equation. Then you will obtain your displacement is in 2 meter, positive 2 meter. Okay. Okay, so in order to get velocity, so means that you need to differentiate displacement. Okay, so you just differentiate the displacement equation ds over dt. So you will get 3t squared minus 18t plus 15. Okay, when you differentiate displacement, you will get this equation, which is the equation of velocity. So what you need to do, you just substitute t equal to 2 seconds in the velocity equation. Okay, in order to get the acceleration, you just differentiate the equation of velocity. Okay, with respect to time, you get 6t minus 18 and then just substitute t equal to 2 seconds. Okay, now you will obtain the velocity, displacement, velocity, and acceleration at t equal to 2 seconds. Okay, so now the question asks you, the second question is determine also the distance travels or the duration of 0 to 6 seconds. Okay, means that you need to know the distance traveled by the particles. Okay, so now distance travel for 0 to 6 seconds. Okay, so you have the equation of s equal to t cubed minus 9t squared plus 15t. Okay, so the time given here is just 0 to 6. Okay, what you have to do, you just substitute the value, the range of time from 0 to 6 in this equation. Okay, in the displacement equation. So you may notice that at t0, the displacement is 0 meter. At t equal to 6, the displacement is negative 18 meter. Okay, so as I mentioned previously, there is a condition where the velocity will be equal to 0. Okay, the first one is start from rest, The second one is stop moving. The third one is change direction. Okay, as given here is a displacement equation. Okay, as I mentioned, displacement equation has a direction. Okay, has a direction. Okay, it has a tendency between 0 to 6 seconds. There is a change of displacement direction. Okay, how to know that we have a change of the displacement direction? We will use the velocity equation, because we know that from velocity, we will know that when v equal to 0, there is a change in direction. So what we can do here, we can say the particle change direction when v equal to 0, or ds over dt equal to 0. So the second step here is to check either the particle change direction or not by using the velocity equation. Okay, so what you have to do, you differentiate displacement with respect to time in order to get the velocity. You may notice that you will get a quadratic equation. Okay, so from the quadratic equation, you need to solve it in order to get the roots. Okay, in order to get the root, you can use your calculator to get the root. So from this quadratic form, okay, from the roots, the times here, you will notice that from this velocity equation, you will get the root is t equal to 1 and t equal to 5 seconds. Okay, from the analysis v equal to 0, you obtain another 2 times here, which is 1 second and 5 seconds. Okay, therefore the particle changes direction when t equal to 1 and t equal to 5. Okay, what you have to do here, the t equal to 1, you substitute 1 second and 5 seconds into this equation, displacement equation. Okay, so when t equal to 1 second, you will get 7 meter. Okay, so the particle changes direction when when displacement equal to 7 meter. Okay, so then you just substitute again when t equal to 5 seconds into the displacement equation, and you may notice that at t equal to 5 seconds, you have another displacement which is negative 25 meter. Okay, okay, now in order to obtain the distance travel, means that you need to draw the path. Okay, from the start to the end. Okay, from 0 to 6 seconds, you need to draw the path. Okay, here you have 0 second. From 0 second, you obtain t equal to 0 second, you obtain s equal to displacement equal to 0 meter. 0 meter. Okay, then you have t equal to 1 second. T equal to 1 second, you have 7 meter. T equal to 1 second, you have 7 meter. And then t equal to 5 seconds, you have here is negative 25 meter. And then t equal to 6 seconds, sorry. 6 seconds, you have, this one is 25. You have here is negative 18 meter. Okay, here please note that change direction. Here also the same, change direction. Okay, what you have to do, you need to draw a timeline here, a displacement line. Okay, here is S, M. So you may notice that at t equal to 0, S equal to 0. So you put here S equal to 0, t equal to 0. And then at 1 second, you have S 7 meter. So S equal to 7, t equal to 1. Okay, let's say I put here. t equal to 0, t equal to 1. So here is the starting point of your particle. Here is the second point. So it's moved here to the right. Okay, positive 7 meter. And then at this point, it's changed direction. So meaning that it changed to this direction. Okay, and the third point here is t equal to 5 seconds, s equal to negative 25. So you put here s equal to negative 25, t equal to 5. So here is the third point. Okay, at this point also it's changed direction. So it should change to here. So the last point here is negative 18. So s equal to negative 18, t equal to 6. So this is the timeline, this is the displacement direction for your particles. Okay, it's moved from 0 to 1 second. At 1 second, it changed direction and moved to 5 seconds, and it changed direction again. And this is the end point. So start here and end here. So you need to calculate the distance traveled by the particles. Okay, the total distance. So here is the first distance, 1. Okay, here to here is the second distance, and from here to here is the third distance. Okay, so in order to calculate the total distance, okay, at point 1, 0 to 7, so 7. Okay, we just take the magnitude. Okay, we just take the magnitude because the question asks you distance. Okay, distance is a scalar unit. So you just take a magnitude which is 7 meter plus with from here to here. Okay, which is 32 32 meter plus with from here to here which is 7 meter. Then you will get 39.46. So this is the total distance. Okay, any questions so far? Ada soalan ke?
No.
Clear?
Yes, sir.
Okay, if no question, I will proceed. Okay. Okay, so far so good. Okay, so this is another example. Now you are deal with a graph profile, which is a V against T graph, which means that velocity, the y-axis is velocity, and the x-axis is a time graph. Okay, so in this example, it's mentioned that a particle move on a straight line, which is a rectilinear motion, with a velocity profile shown. Okay, in this graph, it's just give you the information regarding velocity and time. Okay, in the question, it provide you the additional information regarding displacement, which means that at this point here, the time equal to 0. Okay, let's say I put time equal to 0 second, then displacement equal to negative 50 meter, and also you have the information of velocity negative 6 meter per second. So this is the initial information that you obtain from the question. Okay, so from here it's mentioned that determines acceleration when t equal to 7 seconds. Okay, and then acceleration when t equal to 20 seconds. Displacement when t equal to 10 seconds, distance travel for the duration from 0 to 25 seconds, and then displacement at t equal to 12. 12 meaning that somewhere here. Okay. Okay, so from the graph, as I mentioned, we can get the equation. Okay, we can get the equation from the graph. Okay, we know that if you have a straight line graph, you can, if you are familiar with the equation like y equal to mx plus with c. C is the y-intercept, m is the gradient. Okay, for this case here, we have v against t graph. So our y now will become velocity, m is the same, x will become t plus with c. So this is your equation of the straight line in the vt graph. Okay, so from this equation, you can generate from this general equation, you can generate the equation of each line. Okay, let's say from here to here, you can generate the equation. From 10 to 15, you can generate another equation of velocity. From here to here as well, you can generate another equation. Okay, so for the solution, you may notice that for 0 to 10 seconds, you have the equation of a straight line v equal to mt plus c, because from 0 here to 10 seconds, you have the same gradient of the graph. Okay, basically we can directly use this from 0 to 10. Okay. Okay, so in this graph, in order to determine the unknown gradient and y-intercept, you need to have 2 points. Okay, because we have two unknowns here. Two unknowns require two equations to solve. Okay, so the easiest way to determine the point, you just take the point here, and then you take the point here. You have 2 points. So here you have t0, v negative 6. Okay, at this point here, you will have t is 10 second and v is 10 millimeter per second. So you have 2 points. So what you have to do next, you substitute each point into this equation. Okay, when t equal to 0, v equal to negative millimeter per second, meter per second, you will get negative 6 equal to m times with t0 plus with c. So c is equal to negative 6. So you obtain one unknown. Okay, basically from the graph, we directly know that here is the y-intercept. Okay, so then you input the second point, which is 10 second and 10 meter per second. You will get 10 equal to m times with 10 plus with c. So 10 10m minus with 6. Then you will get m is equal to 16 over 10. So m is equal to 1.6. Okay, so now you obtain negative 6 and 1.6. So what you have to do, you just substitute m here and c here. Okay, so this is your equation of velocity from 0 to 10 seconds. Okay, so when you have the equation, you can differentiate or integrate depends on the question asked for. Okay, let's say here, the question A is asked for acceleration when t equal to 7 seconds. So 7 seconds is between 0 and 10. So means that you can use this equation. Okay, this equation is valid from time 0 to 10 seconds. So but then the question asks you acceleration, but this equation only for velocity. What you have to do, you just differentiate this equation, dv dt. Then you will get 1.6 meter per second squared. So meaning that from 0 to 10 seconds, the acceleration is constant, 1.6 meter per second squared. Okay, because from the gradient, we notice that the gradient is the same from 0 to 6 seconds. Okay, so that's why when you differentiate, you will directly obtain the constant value, which is 1.6. Okay, since acceleration is constant. Okay, so if you want to determine the displacement, Okay, we know that V equal to ds over dt. So if we rearrange this equation, we get ds equal to V dt. So what we have to do, we will integrate this one. Okay, you will get s equal to V dt. Okay, you need to integrate V with respect to time. Okay. So, for the displacement, why do you need to determine the displacement? Because you need to use this displacement information to obtain distance travel for the duration of 0 to 25 seconds. Okay. So, as I mentioned, we have this kind of equation, ds over dt. Okay. So let me erase this one first. Okay. So now you are at this area. Okay, you are at this 0 to 10 seconds. Okay, this is the area that you covered. The equation covered from this area. Okay, so this is the area that been covered by this equation. Okay, from 0 to 10 seconds. Okay, so at here, you know that time 0, v negative 6 meter per second, and displacement is negative 50 meter per second. So now, you need to determine the displacement. Okay, meaning that this information is important to you. Okay, this is the initial. So when you integrate this displacement and velocity with respect to time, you need to put the lower limit and the upper limit of the integral. Okay, the upper limit and lower limit of the integral. So here, differentiate with respect to displacement. Here, differentiate with respect to time. So for the displacement, the lower limit and the upper limit should be displacement. For the time, the lower limit and the upper limit should be in time. Okay. So, in order to generate or to develop the general equation, we need to have a lower limit value. Okay, we need to have the lower limit value for displacement and time. Okay, so for ds, we know that the lower limit, which is the initial value, is negative 50 meter. So here is the initial value, negative 50 meter. So lower limit is your negative 50 meter. And the upper limit you just put as s because you want to generate the general equation. Okay, and also you don't know what is the upper limit, what is the displacement at 10 meter. You don't have that information. So you just put s. Okay. And then for the limit for the time here, you know that at the initial time, at this time here is 0. So you put the lower limit is 0 and then the upper limit, you just put t, even though you know that the t here is 10 seconds. So you just put t there. Okay, because you want to generate the general equation from 0 to 10 seconds. So that if the question asks you, determine the displacement at 7 seconds. So you can put in the equation to determine the displacement at 7 seconds. Okay. So what you have to do next, you just integrate this one. Okay, if you integrate this one here, you will get like this as negative 50 as equal to 1.6 t squared over 2 minus 60. Which is 0 to t. So what you have to do, you just substitute the limits into this equation and into this equation. You will get upper limit minus lower limit. So upper limit s minus with the lower limit is negative 50 equal to, okay, so the lower limit is 0. So you just input the upper limit 1.6 t squared over 2 minus 60. Here is minus 0 because the lower limit is 0. Okay, then if you rearrange the equation, you will get the general equation of displacement from 0 to t to 10 seconds. So this is the equation for displacement. Okay, so now you know that at this point here, t equal to 10 seconds, you can get the displacement, which is negative 30 meter. Okay, clear? Anyone? Do you have any question? Clear till now? Okay. So now we solve for the first part from 0 to 10 seconds. So what we need to do next is we do on 10 to 15 seconds, which is the second part. Okay, the second graph profile, which is this part here. From 10 to 15 seconds. We do the same things like previous one. We will have the general equation V equal to mt plus with C. So here you need to know 2 points because you need to determine M and C. So here is the first point, here is the second point from 10 to T to 15. Okay, so you will generate the equation from 10 to 15 seconds. Okay, so this point here is 10 seconds with 10 meter per second. And this point here is 15 seconds with 10 meter per second. So you have 2 points. So what you have to do, you just substitute into this general equation. 10 equal to m times with 10 plus with c. First equation. And then you input the second point. 10 equal to m times with 15 plus with c. Then you get a second here. So you need to solve this simultaneous equation. Then you will be able to get gradient equal to 0 and c equal to 10. Okay, c equal to 10. So gradient 0, c equal to 10. So basically v equal to 10 seconds. Okay, so sorry, v equal to 10 millimeter per second, meter per second. Okay, so this is the equation of the velocity. Basically, you can determine it from the graph. You know directly. So since this is no gradient graph, a straight line with no gradient, so you just know that v is equal to 10 meter per second. You don't need to use this analysis. Okay, if you want to double check, you can use this part. Okay, if you understand the graph very well, then you just directly take v equal to 10 seconds, 10 meter per second. Okay, so now the question asks you can determine the acceleration from 10 to 15 seconds by differentiating this v. So dv over dt will get 0 because if you differentiate constant, you will get 0. Okay, so from here you know this is a constant velocity, so you will have a 0 acceleration. Okay, because actually it is obvious from the graph that the velocity is constant, thus the acceleration is 0. Alright, so now after you finish finding the acceleration, you can determine the displacement with this value or equation. So you know that v equal to 10 meter per second. So ds equal to v dt. Okay, so now for this part here, okay, in order to get the displacement, okay, this is your lower limit, this is your upper limit. So lower limit, this is your upper limit. Okay, for this integral limit. Okay, so for the time here, you know here it should be 10. Here should be t. You just put t to make it in a general equation. Okay, so for the displacement, for the lower limit, you need to determine this displacement at this point using the previous equation. Meaning that from here, you know that you already obtained the displacement equation from 0 to 10 seconds. So you can use this equation to obtain the displacement at 10 seconds, which is negative 30 meters. So this negative 30 meter become your lower limit for this section. Okay, for this section, negative 30 meter is your lower limit. So the upper limit is, you just put S, displacement. So the same things, you integrate both sides, okay, then you will get the equation of S equal to 10t minus 130. So this equation, displacement equation, is valid for 10 to t to 15 seconds only. Okay, so if the question asks you determine the displacement in 13 seconds, so you can use this equation. Okay, so when t equal to 50 seconds, the displacement is 20 meters. So why do you need this 20 meter? Because if you want to do the analysis at this section, at this triangle here, this will become your lower limit. Okay. Okay, so now after we finish findings displacement, acceleration, and velocity at the second section, we go on the third section, which is this section here, from 15 to 25 seconds. Again, what we will do, we will determine the velocity equation. Okay, we have v equal to mt plus with c. So now you may notice that the gradient of this velocity profile is negative gradient. Okay, so when you calculate, you need to obtain the negative gradient, which means that negative value of m. So this is your first point. This is the second point. Here is times 15 seconds, 10 meter per second. Here is 25 seconds with 0 meter per second. So you have 2 points here. So what you have to do, you just substitute the 2 points into general equation in order to obtain the m and c, y-intercept. So this will be your velocity equation. Okay, negative t plus 25. Okay, so what you have to do next is to determine the acceleration okay, at this profile by differentiating dv over dt. Then you will get a negative 1 meter per second square. So this is the acceleration at this section. Okay. Okay. So what would be the acceleration at t equal to 20 seconds? Anyone want to try? Or question B, how to obtain acceleration when t equal to 20 seconds? Hello, is anyone here? Y equal to mx plus c. dv over dt equal to a. So which velocity equation? Which section? First section, second section, or third section? So we have here is first section, second section, and the third section. Which section that you need to do dv over dt? Yes, third section. Okay, so when you dv over dt for this equation, you will get acceleration here is negative 1 meter per second squared. So this acceleration is valid between 15 to t to 25 seconds. So any acceleration between 15 to 25 seconds will become negative 1 meter per second squared. Okay? Because you use the velocity equation between 15 to 25 seconds. Okay? Okay, then what you have to do next is you need to determine the displacement between 15 to 25 seconds. So you have the velocity equation, which is v equal to negative t plus 25. So you input the here for the roots. Time here is 15. So this is the lower limit. This is the upper limit. So the lower limit 15, upper limit we just put t. And the lower limit for displacement is from the previous equation, which is 20 meter here. And then the upper limit you just put s. So you solve this integration process, and then you able to get this equation. And this displacement equation only valid for 15 to 25 seconds. So if the question asks you determine the displacement at 17 seconds, then you can use this equation. Okay. Alright, so here when t equal to 25 seconds, you obtain the displacement is 70 meter. Okay, so for s when t equal to 10 seconds, you already solve it, which is here. Okay, here which is negative 30 meter. So this is the question for s. So you solve for b and c. So then d. So you need to solve for question D. Okay. So now here, okay, let's me list. Okay, from time with displacement. So this is time. This is displacement. At 0 second, the displacement is negative 50. Okay, at 10 second, your displacement is 10 second is negative 30 meter. Negative 30. At 15 second, you obtain 20 meter. And at 25 second, you obtain 70 meter. So this is the the time frame with respect to the displacement. But then when we want to calculate the total distance traveled, means that we need to know either the particles change direction or not. Okay, in order to know the particle change direction or not, we need to use the velocity equation, which is equal to 0. Okay, velocity equation equal to 0. So we know that for the first part here, we already obtained this velocity equation, 1.60 over negative 6 at minus 6. 1 over 60, 1.6 times t minus 6. So this is the velocity equation equal to 0. Because we want to know the change in direction, velocity will be equal to 0. So when you calculate, you will notice that the particle changes direction at t equal to 3.75 seconds. So meaning that here you have the time 3.75 seconds change direction. So what you have to do, you substitute t equal to 3.75 seconds into displacement equation between 0 to 10. You need to use this equation because 3.75 seconds is between 0 to 10 seconds. So please use the equation between 0 to 10 seconds for displacement. Okay, so you obtain negative 61.25. So here meter. Okay, then we go on the second section. We have the velocity equation is 10 meter per second. So if we no equation, just a constant value, means that particle did not changes the direction. Alright, then we go on the third section here. We have 15 to 25 seconds, and the equation of the velocity is negative t plus 25. So if you equal to 0, you will get that t equal to 25 seconds where the particle change direction. Okay, so here is the actually the particle change direction. Okay, so now you have list all the time with respect to displacement, include the change in direction. Okay, so what you have to do, you just draw a line for displacement. Okay, let me just use the example with this note here. You have a line of with displacement. So the first point is 0 second with s negative 50. Okay, so 0 second as negative 50 meters. So this is the line for displacement. So here is the first point. Okay, the point here. Okay, then the second point is time 3.75 and the displacement is negative 61.25. So the second point 3.75 seconds and this is the displacement. Okay, the second point, and then go to the third point 10 seconds with negative 30. So here is negative 30 10 seconds. Okay, then you go on the fourth point 15 seconds 20 here 20 meter 15 seconds, and then the last point is 25 seconds with 70 meter 70 meter. So this is the last point. So here is your uh, flow of the particle. Okay, the flow of the particle from negative 50 meter to 70 meter. So what you have to do, you need to calculate the distance traveled. So from here to here, okay, which is from here to here is 11.25. Okay, we just take the magnitudes. Okay, for distance, don't take the direction. Negative here is for the direction of displacement. In order to calculate the distance traveled, we just take the magnitude. Okay, from here to 0 here is 61.25. From 0 to here is 70. Then you can calculate here, you get 5, 2, and 4, 142.5 meter. Okay, so displacement when t equal to 12 seconds can be obtained from time section 10 to 15 seconds. So you have here is question E, when t equal to 12 seconds, what is the displacement? So you just use this equation. Okay, because this equation is valid for 10 to 15 and 12 is between 10 to 15 seconds. So then you will obtain what is the displacement. Okay, any questions so far?
No.
Okay, so if you have no question, maybe we can go to to this example 2.7. Basically, it's the same, okay, as as the previous example, but then we will do on the approach, which is graphical approach. Okay, for this 2.5, we do on the equation approach, where we develop the equation, and from that equation we will integrate or differentiate. Okay, but for this example we will do on the graphical approach. Okay, so you will when we do the integration, okay, when we the integration in the graph, the area under the graph is actually the integration process. Okay, basically here is a v against t graph, v against t graph. So if you find the area under this graph is actually the displacement. Okay, so if you find the area under the curve, it's actually the displacement for vt graph. Okay, for AT graph, if you determine the area under the AT graph, let's say you have this graph, AT graph, Okay, you have the graph like this. Okay, from 0 to t. The area under this AT graph is actually velocity. Okay. Alright. So for this example, what this example did is it want to find what is the value time here from O to A and A to B. Okay, from O to A to B. Okay, basically the question is still the same. Acceleration when t equal to 7 seconds, acceleration when t equal to 20 seconds, displacement when t equal to 10 seconds, and also the distance traveled and the displacement. Okay, the question is still the same with previous example. Okay, so in order to obtain what is the time here from O to A and A to B, we can use triangles analysis or mathematical identities of a similar triangle. So here we can see that from 0 to 10, we can see this is the kind of the triangle. Okay, so in order to get the ratio or the identities between this triangle, we know that we have the angle theta here. This angle is same to this angle. Okay, if I want to find this angle, I will use tangent theta equal to tan over y. Okay, for the big triangle. And for the small triangle, I get tangent theta is equal to 6 over x. Okay, so basically the theta is the same. Okay, theta here is the same, so you can put here 10 over y equal to 6 over x. Okay, basically it's the same with this here. Okay, so x plus y is equal to 10 seconds. So we will have the equation of 10 over y, 6 over x, equation number 1. Then you have x plus y equal to 10, which is your equation number 2. Okay. So if you rearrange, you saw the simultaneous equation, you will obtain the value of x and of x and of x and y. So basically x is equal to 3.75. Okay, and then you will find the y. 1 second. Okay, so now you know that this is the section here, the first, second, third, and the fourth section. Okay, so basically for me, you just use 0 to 10 just in one section because it has the same gradient. Okay, it has the same gradient. All right. So for this case here, you may notice that what the in the example did is it tried to create the acceleration against t graph. Okay, the acceleration against t graph. Okay, we know that it's actually in the books. If you notice that the first, let me copy from the books. Okay, this is the first step in the books where it makes that this is the first section, second section, third section, and the fourth section. So what in the books teach is we know that on the AT graph, if we find the area under the graph, we will obtain the velocity. Area under the acceleration graph, we will obtain the velocity. So what in the books did that, since we know this is increasing positive gradient. So when we have a positive gradient, means that you will if you differentiate positive gradient, then you will get a positive value. Okay, let's say you have v equal to mt plus c. So you differentiate dv over dt, then you will get m. So you just get a constant value of m. So from here, you have, let's say, v equal to mt plus c. Okay, so then if you differentiate this one, you get m. So that's why it put here just a constant. Okay, from 0 to a, first section. But then still we don't, since we don't know what is the value of gradient from here to here, in the books, it's just assumed that it might be somewhere here for acceleration from this point to this point. Okay, one is O, A, B, C, and D. Okay, so since we have a positive gradient graph, so means that the acceleration should be in positive value. Okay, so then we have the third section here from B to C. Since we have a constant velocity, so that's why we will have zero acceleration. Okay, and then at the fourth section here from C to D, we have a negative gradient graph, so we just put the acceleration at negative value. So at this graph, we don't know what is exactly the value of this acceleration. We just make the assumption, so the graph may look like this. Okay, the graph of the acceleration may look like this. Okay. So what we do next here is that we do section by section. Okay, we do section by section. So as I mentioned to you, area under AT graph you will get a velocity. Area under acceleration against time graph you will get velocity. So you know that at this area, which is O to A, okay, O to A, time with the time here. So the time here should from here to here, the first section. So you know that this here is x. X here is 3.75 seconds. Okay. So length time with height. Okay. You get the area under this graph. So so you don't know the height, which is just acceleration OA. So acceleration OA, the height, time with the length 3.75, then you obtain negative equal to VA minus VO. Okay, VA minus VO. Okay, which means that VA here to VO here to VA to this point. Okay, from this point to this point. So this is the velocity VO and VA. So we know that VO is -6, VA is 0. So you know VO -6, VA is 0. So you just substitute into this equation, then you will get acceleration is 1.6 meter per second squared. Okay, that one is for the first section, which is this section. Okay, then you go to the second section. Okay, so the second section, you do the same things. From this graph, you find the area under this graph. So basically is what is actually AAB time with 10 minus 3.75. So VB minus VA. Okay. So this is point B, which is 10 meter per second, and then this point A is 0 meter per second. So VB 10, VA 0. So then you're able to get acceleration A to B is 1.6 meter per second squared. Basically, it's the same. Okay, it's the same. So that's why here you see the graph from O to B is the same line. So this is just the assumption that, first assumption that we made. Okay, basically from this graph we know it's the same gradient, so basically we have the same constant value of acceleration from 0 to B, so 0 to 10 seconds. Okay, so for the third section, you don't need to calculate the area because the area is, there is no area for this section, so you just put the line on the t-axis. Okay, and the acceleration at this part here will become 0. Okay, so the second point here, the fourth section, you find the area under this graph, which is ACD, the width, the length of this graph, time with sorry, it's not the width, it's the height. ACD is the height because this is acceleration, so ACD is the height of this graph. ACD times the width here, 25 minus 15 equal to VD minus with VC. So where you want to get VD and VC? So here is VD, here is VC. Okay, so VC is 10, VD is 0. So then you're able to get acceleration at C to D. Okay, so why do you get it's actually it's already put negative here because from this graph it's below the t-axis, so that's why the answer here is positive, means that our assumption that we made here is correct. Okay, if you already put the negative. If you didn't put the negative at the front, then you get a negative value. So means that to show to you to you that this acceleration is actually negative acceleration. Okay, below the T graph. Okay, so after you finish complete from 0 to 25 seconds, then you can draw a correct acceleration graph. Okay, so from 0 to 10 seconds, so this is actually the acceleration graph. And from 10 to 15, 0 acceleration, 15 to 25, you will get negative 1 acceleration. Okay, so its answer for question A and B. T equal to 7 seconds is located somewhere here, so 1.6 meter per second squared. T equal to 20, 20 is somewhere here, so it's negative 1 meter per second squared. Okay, any questions so far? Ada soalan tak? Kalau ada soalan boleh tanya. Kalau ada, if you have any problems, alright. So the one is for acceleration. Okay, so now from the VT graph, we can form a ST graph or displacement against time graph. So for the if we already have V against T graph, so what we need to do here, we just determine the area under this graph to obtain the displacement. For previous part, we need to first assume what would be the shape of acceleration, because from the shape of the assumption, then we can generate the correct acceleration graph. That for the displacement, you don't need to make the assumption. You can directly form the displacement graph, because from the velocity profile, area under the graph will be the displacement. Okay, so now you know that from 0 to A is 3.75 seconds. So area under this graph is actually 3.75. This is triangle. Okay, so triangle is 1/2 times with 3.75 times with -6. So this is the area under the area of the triangle for the first section. Okay, so it is equal to SA minus SO. Okay. So given in the question, SO is -50 meter. So then you will able to get SA. Okay, in the question is provided to you at at the time 0, the displacement is -50 meter. Okay, from A to B, you have 6.25, so it's still the same. 1.2 times with 6.25 times with 10 is SB minus SA. Okay, SA is you already calculated here. SA, so you just substitute here, then you will get SB. Okay. Then for this area, it's just a rectangle. So 5 to 15 minus 10 times with 10. Then you get 50. So equal to SC minus SB. So like this. Okay, SB here, just substitute from the previous section. Then you get SC. Okay, and then for this section, it's a triangle, so half time width time with height. So 1/2 time with 10 time with 10, then you get ST equal to 70 meter. Okay, so now in order to generate the profile for displacement for displacement graph. Okay, so this is come where you need to understand where I mentioned in a previous slide. Okay, regarding this slide here. Okay, regarding this slide. Okay, if you have a positive gradient, if you integrate positive gradient, then you get this shape of graph. If you obtain a negative gradient, if you integrate negative gradient, then this will be your shape of the graph. Okay, so if a positive constant, then you get positive gradient. Negative constant, negative gradient if you integrate. Okay, why we're talking about integration? Because in order to get displacement, you need to integrate velocity. Sorry, yes, in order to get displacement, you need to integrate velocity. Okay, so in order to generate a displacement profile, you need to integrate the velocity. Okay. Okay, so here at this point here, you know that the displacement is negative 50 meter. So you draw an axis of displacement against time. So displacement against time. So at this point, the displacement is negative 50. Okay. So at this point A here, the displacement here is negative 61.25. So here is negative 61.25. Okay, and then go at the 10 second. At the 10 second, the displacement here is negative 30. Okay, so 10 second, negative 30. Okay, at the 15 here, you obtain 15 at section BC. Oh, yeah. Okay, at the 15, you don't have the information about that. Okay, you don't have the information, but you know you have a constant velocity. If you integrate this constant, you will obtain positive gradient. So from 10 to 15 here, you will have a positive gradient graph. So actually here is 20. Okay, SC here is 20. Displacement here is 20. Okay. Okay, this is section C, section B. Okay, correct. So section C here you have 20, section B here is negative 30 for displacement. Okay, so for D you have here is 70 meter, positive 70 meter. Okay, now you have a 1, 2, 3, 4 and 5 point. How to connect the point? You need to look at the gradient. So for this graph, you have positive, for this section, you have positive gradient. So as I mentioned previously, for positive gradient, you will have this shape of graph. Okay, for positive gradient, this will be your shape of the graph. So from 0 to A, so it should be like this. Okay, should be like this. Okay. Like that, and then from A to B is also positive, so continue with like the same shape. Okay, and then from B to C is a constant, so if you integrate constant, you get a positive gradient, so you will have a positive gradient. So positive gradient means that a straight line with a gradient. So this is the straight line. This section is a straight line. Okay, and then from C to D, you have a negative gradient. So means that the shape of your graph, if you integrate like this. So from C to D, your graph should look like this. Okay, so this is your shape of the graph. Okay, you have a positive gradient from here to here. You have a constant and then you have a negative gradient. So this will represent the shape of displacement graph. Okay, it depends on the gradient of the velocity. If you have positive, then it will look like a smile shape. If you have a negative gradient, then it will like a sad shape. Okay, sad face. Okay, if you have constant, if the constant is positive 10, then you will have a positive gradient. So here is positive gradient. Okay, so now the question asks you what is the total distance travel for the duration 0 to 25 seconds. Okay, what you have to do, you just calculate here. So from here to here, means that 11.25, and then from here to here, which is 61.25, and then from here to here is 70. Then you get 11.25 plus with 70 plus with 61.25. Then you get the total distance travel. Okay, you have from here to here is 1. Okay, then from here to here is another 1, and then from here to here is another 1. Okay. Alright, so this is the total distance travel. Okay, so I think we are already at 1 p.m. Okay, so I think I will finish my lecture until this slide. Okay, any questions so far?
No questions, sir.
Okay, so if you don't have any question, I think that's all for today. Thank you very much. And if you want a hard copy book, please contact me as soon as possible. Okay, if you are at UTM, then you can come to my office. The price without the postage is 40 ringgit. Alright guys, thank you. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Thank you, Dr.
Salam,
Thank you,
thank
sir.
you.
Thank you, sir.